Our product is Poraver, which actually stands for porous glass in French. It is made from recycled glass that we receive from municipalities in Ontario, Canada. Green, brown, red, yellow, it doesn't really matter. We can actually accept some contaminants in it as well, such as ceramics, which is a real no-no for the glass manufacturing business. We can accept some metals and even some paper and plastics. We grind the material down to 35 microns, and we use agglomeration techniques. We first take binders, expanding agents, and we create obviously a slurry and then produce this product right here, which we call green grain. Green grain contains less than 0.2% moisture in it, and it can basically sit on the shelf for years, and we can then expand it afterwards. This is the final product. Has a very high compressive strength. Again, we go from 10 pounds of cubic foot density up to about 30 pounds of cubic foot density, and that is obviously the smallest size, which is 100 to 300 microns, and we go up to 4 to 8 millimeter in diameter. Has a very high compressive strength. It is blown up at 850 degrees Celsius, and it has a very short residence time in the kilns. So we can manufacture over 30,000 metric tons a year at our plant currently. And what you're looking at is the final product, which came from recycled glass. One of the benefits of Poraver that everyone should be aware of is, first of all, its spherical nature. Being round means less fatigue on someone that's actually applying the product. And in the industrial applications, in a manufacturing facility, it means that you have less wear and tear on your equipment. Even though this is glass and is very abrasive, it flows very easily. At the same time, it doesn't get degraded if it goes through, let's say, mixers, or it goes through moino pumps. There'll be no degradation because it has a very high compressive strength, the material itself. The other great attribute of this product is there's very little water absorption. So if you're making a wet mix, a wet slurry, and you're trying to produce poured cement, poured gypsum, block, there will be no issues with increased viscosity in your mix. The only way you could increase viscosity is if you leave the product in water, let's say over 48 hours, and you may get some capillary action occurring, and that's when you will see increased water absorption. But for actual mechanical mixing in a slurry, you have absolutely no issues, and you will not be required to add more water, so you can actually get down to the lowest possible water content for proper hydration of cement, let's say at 28%. The beautiful part about Poraver, and this is the biggest secret of Poraver, is we have a very high compressive strength of Poraver. But if you look at the surface compressive strength, it's very weak. So basically you can take a pin and you can easily go through the Poraver bead, and that is one of its main attributes for ASR, which is alkali sucker reaction. When gelling occurs, the gel actually wants to move in the direction of least path of resistance. So instead of going back into the cement and expanding it, it'll actually puncture the Poraver bead, enter it, and over time it'll neutralize, which means there will be no more silica-alkali reaction. For the exact same reason, a lot of applicators, a lot of manufacturers try to add, let's say, foaming agents, at least 4%, minimum 4%, in order to try to avoid freeze-thaw in the northern climates. The issue is, if you're manufacturing by trying to consolidate the concrete, then you can absolutely not use foam, because you would degrade the foam bubbles. The beauty of this product, again, is it's a multicellular structure. So if you have water entering cement, as we all know, water gets absorbed into cement over time, you would have the crystals of water expand and enter the bead, and it would not fracture the interior of the cement, and you will not get delamination occurring. Our product is Poraver, Por for porous and Ver for glass. Poraver in Ontario, Canada.